Welcome to today's online MECLA event. Hello to everybody from wherever you are zooming in. You're joining the Materials and Embodied Carbon Leaders Alliance for our spotlight on aluminium, shifting towards low carbon and recycled aluminium. Before going any further, I would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. I'm speaking from a pretty chilly Gadigal land, and I pay my respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples participating today. My name is Hudson Worsley from Precinct, and I have the great pleasure of being MECLA's chair. Just so you know, we are recording today's event. Now, I'm delighted to report that we have 67 founding partners of MECLA from right across the construction and materials ecosystem. So thank you to all of these organisations. You give us strength and breadth and demonstrate that low carbon and zero carbon construction materials is an idea whose time has certainly come. Thank you to WWF for its support and resourcing, and thank you to Monica Richter, MECLA's Executive Director, for her never-ending efforts to make MECLA happen. Thank you to Tello Gurin from the New South Wales Government for continuing to support MECLA and for his work navigating the machinery of state government, and importantly, for his work extending MECLA's reach across other levels of government. More on that to come. I'd like to remind all founding members and attendees that MECLA operates under an agreed governance framework and that we do not engage in anti-competitive behaviour. Our governance framework is based on the values of collaboration, integrity, leadership, opportunity and transparency. So this is being recorded and all of our documents are all available on our Google Drive. This collaboration of organisations comes together to drive reductions in embodied carbon in the building and construction industry. We seek to align with the Paris Agreement targets and principles of circular economy and recognise that the building and construction sector is a complex ecosystem. To do this, we have established MECLA as a do tank. This means working together to overcome the barriers to the uptake of low and zero carbon materials. And our working groups are the doers. Working Group 1, articulating the demand for low and zero carbon materials. Group 2, defining a best practice evaluation framework for embodied carbon benchmarking. Group 3, providing a platform that will enable the sharing and rapid expansion of knowledge around opportunities and capabilities in the sector. 4, developing common language for design specifications, for procurement guidelines and tendering criteria. And our material subgroups, 5A, B, C and D, diving deep into solutions for steel, cement, aluminium and other materials. So to our working group chairs, deputy chairs and members, thank you for your doing. Now, if we were meeting in a physical location, we would already have bumped into friends and colleagues, some old, some new. So to replicate a virtual random bump into session, we'll break into random breakout rooms. Please say a quick hello and introduce yourself, hopefully to someone new. Today's topic, we have a content-packed lineup of speakers. Aluminium. We know it's a critical material for the modern world and momentum is growing to drive decarbonisation and recycling efforts. But we also know that that's not easy. We know many in the sector are seeking to buy lower carbon and recycled aluminium products for their projects. So here we are. For this spotlight event, our first such event to focus on a particular material, we've asked for industry perspectives from across the building and construction sector, including architectural design, circular economy and demand side, and as well as an aluminium industry expert. Some quick Zoom rules. Many already have, but please keep your full name in the Zoom label so we know who's around. As I mentioned, we're recording this event. Please keep your microphone on mute, unless you're talking, obviously, and use the chat function for comments and questions to be sent through for the Q&A function. We'll be fielding these questions throughout the event. Now, to our first speaker, Marghanita Johnson is Executive Director of the Australian Aluminium Council. She has many years' experience in mining and in particular in aluminium. She'll be talking about Australian aluminium, sustainably value adding to Australia's resources from mine to market. Margie, can I hand over to you?
So thank you for having me here, Hudson and Monica. And firstly, I'd also like to acknowledge the traditional owners of the land on which we meet today. And specifically, I recognise that I'm on the home of the Turrbal and Yagara nations, and I pay my respects to elders past, present and emerging. So today, hopefully I'll give you a snapshot of the Australian industry, where we sit in a global context, and some of the challenges there are in choosing sustainable aluminium. I'll try and focus on embodied carbon in the aluminium in use, but to start off, I'd like to take a step back and look at the industry as a whole. So this is a snapshot of the Australian industry as it is today. There are 5 large bauxite mines. These are located mostly either in the north of Australia or in the southwest. There are also 6 alumina refineries, 4 in the southwest of WA and 2 in Queensland. And there are 4 aluminium smelters, Portland, Tomago, Bell Bay and Boyne. And these are all located in the national electricity market on the east coast. So smelters produce a variety of primary end products, including billet, ingot, block and T-bar. The major mines, refineries and smelters are all operated by Rio Tinto, Alcoa, South 32 and Tomago Aluminium. There are also more than 20 aluminium extrusion presses in 12 plants across Australia. So extrusion presses use billet to form consumer goods like window frames, solar racking, pool fencing. So this is Australia's only downstream manufacturing into consumer goods. So billet, which is what you can see in the bottom right corner, is only produced at 2 of the smelters here in Australia, Tomago and Boyne. Capral is the largest producer of extruder in Australia. The other large extruders include G. James and Inex. But it's worth noting that the primary aluminium producers like Rio Tinto, Alcoa and Tomago do not produce finished consumer goods. They just produce the primary aluminium. So in terms of the industry, Australia is the world's largest producer of bauxite. We produce 107 million tonnes, most of which about 60 to 70% is turned into alumina here and about 40 million tonnes is exported. The next largest producer of bauxite is Guinea in West Africa. Australia is regarded as having excellent standards of management when it comes to bauxite mining and has helped produce the global standard, the Sustainable Bauxite Mining Guidelines. We're the world's 2nd largest producer of alumina and largest exporter. So Australia's got more than 50 years experience in alumina refinery. We also have the global research headquarters for Rio Tinto and Alcoa into alumina technology here. That's really important because that means that Australia is where much of the global research is done, including into low carbon alumina technologies. And this is the technology that will ultimately be the low carbon pathway for the global industry. And we're the world's 6th largest producer of aluminium. As you can see, I've also added, given that we're interested in the downstream capability of the industry here. You can see we're one of the few countries in the world that actually has all these phases of production. You can buy extruded aluminium here, made all the way through the value chain. You can also see that it's only around 10% of primary aluminium actually gets turned into extruded metal here in Australia. And that primary aluminium is only about 10% of what's made with Australian alumina globally. So while consumers are increasingly thinking about where their primary aluminium is sourced from, it's also really important to consider the integrated supply chain from mine to market and all the different sustainability aspects of this, not just the carbon footprint. So the Aluminium Stewardship Initiative provides certification across a range of sustainability measures and allows tracking of materials from mine to market. And Fiona will talk more about that later. So I don't need to convince you guys, aluminium is strong, lightweight, and infinitely recyclable, and its use being highly correlated with GDP. So as countries urbanise, their per capita use increases. It's also highly correlated with a clean energy future. So today, global demand for aluminium is about 95 million tonnes, about 2/3 of which is met with primary aluminium, that is produced from bauxite and alumina, and about 1/3 from recycled aluminium. So by 2050, the International Aluminium Institute, who did this analysis, thinks that even with a very ambitious recycling rate, you'll still only get to about 50% of the needs by 2050 being met from recycled aluminium and about 50% from primary aluminium. So we will still need to make more primary aluminium. That means more Australian bauxite, more Australian alumina, and Australian aluminium. So while recycled aluminium is a key part of meeting the increased demand, aluminium has very long product life. So think about the amount of time that aluminium is in transport, in a car, a plane, a train, or in a building. And so increased demand overall means that primary aluminium is still needed. Also, it's important to note that while aluminium is infinitely recyclable, not all recycled material is equal. So you can't go and take an aluminium that's been produced for one purpose and necessarily just apply it to a different purpose. I'm just going to briefly delve into how alumina and aluminium are made so that the sources of carbon emissions are clearer. This is very high level, so apologies to any technical people in the audience about the parts I'm just going to gloss over. This is how all alumina and aluminium are basically made globally. So alumina refining, which is the part you can see at the top. So the first phase is digestion. So bauxite is finely ground in mills, mixed with caustic under high pressure and temperature with steam to dissolve the alumina content. So the temperature is normally 140 to 280 degrees. You then clarify, so that is to wash out the undissolved mud. Precipitate, so that is to get the alumina crystals to be recovered from the caustic by mechanically stirring. And then you calcine. So the precipitated alumina, which is called hydrate, is washed and dried at temperatures over 1,000 degrees. And this gives you the dry white powder of aluminium oxide, or called alumina. The alumina then goes to an aluminium smelter. So inside a pot or a cell, the alumina is dissolved in a bath of molten cryolite and other materials. In that pot or cell, which is a large rectangular thing, as you can see pictured there, the cathode in that is the carbon blocks and insulating bricks that line the cell. You then pass an electric current through the pots via an anode. So the anode is made of carbon, and it's that continuous use of electricity at about 950 degrees that splits the alumina from the oxygen, the aluminium, I should say, from the oxygen to give you pure aluminium. At regular intervals, you then tap the aluminium out and take it to the cast house and then cast it to form ingot, slab, billet, or T-bar. So the most energy intensive or carbon emitting parts of the process are the digestion of the bauxite into solution. That uses about 70% of the energy in making alumina, and the calcination, which is driving off the water at very high temperature. In terms of the smelting part, it's the consumption of the carbon anode in the cell, which releases CO2, and electrolysis, which is obviously the use of electricity. It's really important to note with smelting, though, that while it's very energy intensive, it can be done with any reliable source of electricity. So hydro, geothermal, firmed renewables, with no technological change inside the cell. That's really important because one of the big barriers to decarbonisation for many industries is that you need new technology to be able to electrify. Aluminium smelters, we're already fully electrified. So Australia's alumina is already very low emission. So what you can see here is the global average compared to the Australian average for alumina. Australia's already low emissions because all the Australian refineries already have some form of cogeneration of heat and power in their plants, making them more efficient, plus a relatively high penetration of gas usage. But there are opportunities to go lower, and I'll talk about those more in a minute. And this is the aluminium smelters are starting higher up the intensity curve. But there's a big difference between the Australian production and global production. So globally, 2/3 of the aluminium sector's electricity needs are met by captive power stations. That is, those owned and operated by aluminium producers. And many of those are new thermal captive power stations. So the time from a new power station to retirement is quite long. In Australia, all the smelters are grid connected. So we're decarbonising at the rate of the grid. We are also providing a really important enabling function in grid stabilisation, which is actually increasing the capability of the grid to have increased penetration of renewables. So this is the mine to metal emissions. So that's tonne weighted for the amount of alumina needed to produce a tonne of aluminium in Australia. So you can see the biggest sources of carbon. The first one is the electricity used in smelting. But again, all the smelters are connected to the electricity market and are decarbonising at the rate of the market, as well as enabling that increased penetration of renewables with their stability options in the grid. The second largest source is the smelting directs. So this is the carbon anode that's used in smelting. The third largest source is the direct emissions in alumina refining. So that's the gas and coal that's used to raise the steam for digestion and then also to calcine the alumina. And the fourth largest is the PFC. So these are the only processed gas which are emitted and are a byproduct of the smelting process. Beyond that, the tiny little boxes you can see are the indirect emissions from refineries. So electricity, again, already decarbonising with the grid. And then the tiny orange box is the emissions from bauxite mining. So looking at these four largest sources of emissions and what's needed for Australian aluminium to decarbonise. Number one, the smelters are providing the stability, security and reliability, which is helping the grid to decarbonise. We've already seen the grid decarbonise by about 25% in the last 5 years, and it's going down even rapidly now. The second largest and fourth largest sources are around the zero direct emission smelting. So if you could replace the carbon anodes with inert anodes, you would eliminate the emissions associated with not only that carbon anode, but you'd also eliminate the PFCs or the processed gas emissions. So there are two major projects going on globally on this. ELYSIS in Canada is a partnership between Rio Tinto and Alcoa. You'll recognise those are two smelter operators in Australia, as well as with Apple. And they're trialling a new technology which they're aiming to have commercialised by 2024. There's also another trial run by EN Plus, which is the parent company of Rusal, who also has investments here in Australia in the alumina market. And they are actually already at commercialisation, but in a slightly different way. So both of these types of technologies could be retrofitted to an aluminium smelter here in Australia once fully commercialised. It would take major capital investment and it would need to be combined with the right energy market. And the last point is low carbon alumina. So Australia is, as I said, the world's second largest producer of alumina, and this is where we're doing a lot of the research. We partner very closely with ARENA as well as some CRCs. Couple of projects which have already been announced. One is mechanical vapor recompression. That would potentially remove 70% of the emissions associated with alumina production. Technical and commercial feasibility projects underway. There's also concentrated solar thermal, which has the potential to reduce emissions by 45%, noting that those are alternate technologies, not additive. And we're also looking at hydrogen and CCS options for low carbon alumina. So we have pathways to decarbonise Australian alumina. It's just going to take us and the rest of the world a little while to finish commercially and technically testing these technologies. But thank you and happy to answer questions later.
Thank you very much for that. I think a whistle stop tour, and I appreciate having to do it so quickly and considering the complexity of the chemical engineering, mining engineering that all goes into that. Thank you very much. That was very, hopefully a good introduction for many of us who aren't material experts. I think the fact that so much of the process is already electrified and the grid services that can be provided by the big energy users, the smelters, means you're part of the solution, which is a very helpful place to start. So thank you. I look forward to having your thoughts discussed as we move through our speaker list and into the Q&A.